With that, please welcome Jonathan Leitschuh and Patrick White.
Hello, everybody. Good afternoon, and welcome to Scaling the Security Research to Eliminate Open Source Vulnerabilities Once and for All. My name is Jonathan Leitschuh. I am a software engineer, software security researcher. I'm the first ever Dan Kaminsky Fellow at Human Security. I'm a GitHub star and GitHub security ambassador, and you can find me on Twitter at @jleitschuh and on GitHub at @jleitschuh as well. And Patrick?
Yeah, I'm Patrick Way. I work from Darren. I'm the Open Rewrite team. I've been writing software for 20 years or more, and excited to be here talking to you today.
So, short disclaimer, we're going to be discussing, so first off, I'm sponsored by GitHub. Second off, we're discussing a SaaS solution that is sold. However, all the tools and infrastructure and everything discussed in this talk is available for free and free for open source. Or not free for corporate, but free for open source. And you can use this stuff in your own security research focused on open source software. And with that out of the way, I want to talk about, so this, the work and my employment is sponsored by the Dan Kaminsky Fellowship. The Dan Kaminsky Fellowship was created after Dan passed away last year. I sadly never got the opportunity to meet Dan. Dan, for those of you who don't know, was the hero that was, he was known as the hero of the internet for his incredible 2008 DNS vulnerability that he helped silently patch. And the Dan Kaminsky Fellowship was created to celebrate Dan's memory and legacy by funding open source work that makes the world a better and more secure place. If you have a project that you want to work on that you think will help improve the security of the internet, Human is accepting applications for the 2022 Dan Kaminsky Fellow currently. So this story started with a vulnerability, a simple vulnerability. And this vulnerability existed in my company's code. It was the use of HTTP to resolve dependencies in my company's Gradle build. And the reason this is important is because if you're using HTTP to resolve your dependencies in a Maven, in your Gradle or Maven build, you can have that connection get intercepted and people can maliciously inject additional code and be running additional code in your CI/CD development pipeline or on your developer machines. And this vulnerability didn't just exist in Gradle builds, it can also exist in Maven builds. This is an example where your dependencies are getting resolved for compiler and test dependencies. And this is artifact upload. So this is the final release artifact for a Gradle or for a Maven build. And with this, credentials are also attached to it, so you're also exposing credentials publicly. And this vulnerability was everywhere. It impacted organizations like Spring, Apache Foundation, Red Hat, Kotlin, JetBrains, Jenkins, Gradle, Groovy, Elasticsearch, Eclipse, Oracle, the NSA, LinkedIn, and Stripe. And so I found this vulnerability impacting all of the open source projects of all these different organizations across their GitHub accounts. And at this point, I realized, I was like, this is bigger than I thought. So I reached out to Maven Sonatype. Maven Sonatype is the pip to the Python ecosystem, the NPM to the JavaScript ecosystem. Maven Sonatype is that to the Java ecosystem. And they said that they looked at their traffic logs and saw that 25% of their traffic was still using HTTP in June of 2019. And so I said, all right, how do we fix this? So I pushed forward an initiative that on January 15th, 2020, all the major artifact servers in the Java ecosystem would decommission support for HTTP in favor of HTTPS only. And we published a blog post, I published a blog post, and then I reached out to Maven Sonatype again in January of 2020, and they said that 20% of their central traffic was still using HTTP instead of HTTPS, even after, like 3/4 of a year of trying to disclose this to people. And so you can imagine what happened on January 15th, 2020. Broken software everywhere. But we stopped the bleeding, but this didn't fix the whole problem. What about the other repositories? These are only the most commonly used repositories in the Java ecosystem. Maven Central, JCenter, Spring, and the Gradle plugin portal. Other companies host their own Java artifacts on their own servers, and so you'll see other companies' URLs, build URLs in other builds across the ecosystem. So how do we fix the rest? And I said, well, I mean, opening issues is one way to do this, but like, let's just go fix the problem, right? And so I said, I'm going to try bulk pull request generation. And so how did I do this? First off, the first thing you need to do is you need to find the projects that are vulnerable, right? You need to identify the open source projects that have this vulnerability. And so how I did this was I wrote a CodeQL query for it. And this CodeQL query looks for Maven POM files that have the use of HTTP in this sensitive location in that file, in that XML file, and will flag it. And by scanning, CodeQL scans hundreds of thousands of open source projects on every single commit. And you can run, and they build databases for those projects that you as an open source security researcher can run queries against and find vulnerabilities in open source at scale. And so they also will pay you for queries that you write and contribute back to GitHub as part of the GitHub Security Lab bug bounty program. And so for this simple query, GitHub bountied me $2,300 for this. And using the list of projects that were vulnerable from this query that I wrote, I started generating pull requests. And so the first pull request generator that I ever wrote was Python based. It used a wrapper over GitHub's Hub CLI. It had one nasty regular expression, and there was a lot of logic about bouncing off of GitHub's rate limiting. And this was version 1. It probably looks pretty washed out now, but like this was the first pull request generator. There's an underlying engine, but like this was the logic for generating pull requests to fix this security vulnerability. And this is the regular expression. And the reason that we had to use a regular expression, I had to use a regular expression instead of using an XML parser, is because if you parse XML into an XML parser, and then you modify that XML, the XML that comes back out when you print it back out will be in the format of the XML parser's output, not in the format that came in. And so if you're trying to modify tons and tons of different XML files that have tons of different formatting, you're going to end up with massive diffs. And they're all going to end up looking like the same thing, and you're not going to end up looking like the code the maintainer gave you or started with. And they're not going to be happy. They're going to be like, great, thank you for fixing this, but it doesn't look like the code I wrote. And the other problem is, this is using a regular expression. And when you have a problem that uses regular expressions, you're going to end up with two problems. Because anybody who's working with regular expressions understands this. But it worked. This is my GitHub contribution feed for pull requests when I generated this. And this is an example of the diff that was generated, right? You can see that all the places where HTTP is being used in this sensitive location was fixed. And I generated 1,596 pull requests with this Python bot that I wrote. And as of 2022, today, we've had about a 40% merge rate of those 1,596 pull requests. And for this, GitHub awarded me a $4,000 bounty under the GitHub Security Lab bug bounty program for not just writing the query that found the vulnerability. So this is in addition to the $2,300 for writing the query. This is for actually using that query to try to fix the vulnerability at scale. And I got hooked on this idea of bulk pull request generation as an idea that we could use to fix vulnerabilities at scale across the open source ecosystem. This is my GitHub contribution graph for 2020. You can see the two peaks. I actually did 2 different campaigns in 2020. And you know, this tells a complicated story. So I have a problem. My problem, I have ADHD. That's not my problem, but my problem is that I love chasing squirrels. And vulnerability disclosures are perfect places. Like, you go read a vulnerability disclosure, and you're like, I wonder where else that is in open source. Like, how many other places can I find that vulnerability? And the problem for me is that if I use CodeQL or if I use GitHub code search, I will find too many security vulnerabilities. And for example, this is CodeQL results for zip-slip, right? I can page through pages and pages and pages of results for zip-slip vulnerabilities across open source. So I'm finding too many vulnerabilities. And so I need a way to fix this problem. I can't just report to all these different projects. I need a way to scale my knowledge of security vulnerabilities to fixing these vulnerabilities in a more productive way. And so I need automation. And so at this point, I'm going to pass it off to Patrick to discuss Open Rewrite.
Thanks, Jonathan. Yeah, so that is a challenge. I mean, Jonathan really expressed a couple of challenges that he faced, right? Like, hey, I want to use this regular expression, and of course that's a problem. Or I'm going to use an XML parser, and it's going to come back gobbledygook and not be a viable pull request. So, and then there's scale. How do we detect all these things?
Other way around. Up and down. Lock.
Oh, gotcha. You know what?
There, I got you. Go ahead. There you go.
All right. All right, so he needs automated transformations at scale. And this is where Open Rewrite comes in. You know, somehow, as software engineers, we're professional automators. We automate anything that we can possibly automate. It's just in our blood. It's what we do. But for some reason, in 2022, most of us are still slogging through the tedious task of updating that dependency, finding the breaking change, you know, a framework upgrade, whatever it may be. It's a tedious task, and we like burn our fingers on the keyboard to do it. Well, finally we have an opportunity to do something different. Finally, it is 2022, and now as software engineers, we can start automating our own tedious tasks. And this is one of those projects when I learned about it for the first time, I realized like, this is something new. This is game changing, right? We've been writing DAOs and business logic for who knows how many years, but now you get to write code for your own code. The model that you're working with is your code. It's amazing and it's incredible. So what makes it amazing? What makes it possible? And what really is it? So there's a need to transform code. And it was discovered that, hey, the compiler represents source code as an abstract syntax tree. It's like a compiler's representation of source code. It's bare minimum, but if you look at that tree, you can kind of start to formulate ideas on like, hey, I could transform that tree. I could write it back to a source file, and I could make a diff. I could make some change. Well, that's a nice concept, but again, the compiler's AST is bare minimum. There's no formatting. The compiler doesn't care about comments or spaces or tabs. If you modify that and write it back to a file, you're going to get not a pull request. So one of the first challenges for Open Rewrite was to make this a fully format-preserving abstract syntax tree. So now we have an abstract syntax tree that preserves that precious white space and the comments and all that contextual information that's so valuable to developers, and you can write that tree back to a file that's identical to its origin. So that's a huge unlock. If you're able to do that, we're also able to auto-detect the style. So we need to transform code and write it back according to the style of that particular project. So Open Rewrite will detect like, hey, this is using spaces, this is using tabs, this maybe has 2 spaces in a tab. You know, the nuances like braces on a new line. So all that is done for you by the framework. But there's another challenge. So we got past the fully, the format preserving, but again, a compiler's AST is single level. The type information is not fully typed. So you look at that log.info, and is it log4j? Is it SLF for j? Is it something custom? You need the full depth of type information on that tree. Another problem that was solved by the Open Rewrite team. And with that, what you end up with is we have a fully type-attributed, format-preserving abstract syntax tree. It's syntactically and semantically aware. And if you compare that to the compiler's tree, you can see like, that's dense. There's a lot of information. There's a lot right there that you can use to make accurate transformations at scale that match the format of their source. Well, even a simple tree is a complex AST, right? Just a simple bit of code is a complex AST. If Jonathan is going to do this at scale, we have to provide him with the tools to be able to get beyond the tedium. One of the biggest challenges, is take this little conditional statement here. Jonathan's going to share with you a recipe, a zip slip recipe, in a little bit, and he needs to insert this conditional statement into a block of code. To do that and to handle the formatting and And everything else for all the different projects would be nearly impossible. So what we have is we have a templating engine. The templating engine allows Jonathan to build a tree out of code. So he can write code in Java and build an abstract syntax tree from it. And he can do it in 2 statements. So here's an example of building up a Java template. You can see that there's the conditional statement. It's got some handy features like parameter substitution, and etc. You'll notice that there's not a lot of formatting. And this is where he's going to apply it to the tree. It's got a coordinate system, so he can say, hey, take this bit of code, substitute these parameters, and place it in this spot. In the end, he can go through thousands of repositories, find a vulnerability, and insert that conditional statement exactly where it belongs with the exact correct formatting. And so with that, I'll hand it back to Jonathan so he can share with you some of the more work that he's done on it.
Thank you, Patrick. So with Open Rewrite, with what Open Rewrite provides, what other vulnerabilities can we fix? And what's possible now? So I'm going to talk to you about 3 different security vulnerabilities and talk through Open Rewrite's application to fixing those vulnerabilities. So the first vulnerability we're going to tackle is temporary directory hijacking. So temporary directory hijacking, the basis of temporary directory hijacking is that on Unix-like systems, the system temp directory is shared between all users. This is not applicable to Windows and Mac OS, but on most other Unix-like operating systems, the temporary directory is shared between all users. And this is a vulnerability. This is the way that you will find a lot of Java code creates a temporary directory in Java, where they will create a temporary file, call delete, and call makedir. And the reason that this pattern exists is because prior to Java 1.7, there did not exist an API in the Java standard library to create a temporary directory. And so what people did was this pattern of creating a file, deleting it, and creating a temp directory. And this creates a randomly named, pseudo-randomly, or using a secure random number generator, generates a random name for the file. This also, if you were to look up on Stack Overflow, how do you create a temporary directory in Java, this would have been the solution. And unfortunately, you'd end up with this vulnerability. And so this vulnerability exists here. It's a race condition between the delete and the makedir. And the reason this vulnerability exists is because an attacker can see the creation of the file and see that that file gets deleted and then race the Java process to create the temporary directory before the Java process does. And the reason this is a vulnerability is because makedir, if it fails, returns false. It does not throw an exception. And so the way to fix this vulnerability is to throw that logic into an if block. That's one valid solution, but it's imperfect. And the reason that it's imperfect is because when you use makedir, you're using the default uname set, the default uname, and that will make the directory with all open permissions to let it be. It will not be editable by another user, but it will be visible to all other users. So if you're writing sensitive information into that directory's contents can be viewed by all other local users on the system. And so this is the fix. It's to use the new Java Files API, which has a create temp directory call, which is secure. And this vulnerability that I found a bunch of different places I've received a bunch of CVEs for this. And so I said, okay, there's more of this than just these CVEs. Let's try doing bulk pull request generation. And so that's what we did. And so far, this actually number is not up to date. I did more last night, but I don't know exactly what it is. It's in a later slide. But at least 64 pull requests. And this is what the pull requests looked like. You can see that there's the deletion of the delete and the makedir and the replacement with this new API call. But we can do more complicated transformations than that. Let's say that those makeDirs and deletes were used inside of an if block. You can also remove those because they're no longer needed and just replace it with that single line. Vulnerability number 2 that I want to talk to you about is partial path traversal. So the basis of partial path traversal, let's assume that you have 2 local users on a system, user Sam, and you want to isolate your logic to only operate within the directory user/Sam. And you have another user on that system, user/Samantha. Partial path traversal allows an attacker to access a sibling directory with the same prefix. And so taking this example again, where user Sam and we have user Samantha, if you're sandboxing your logic to user Sam, you can access user Samantha because it's a prefix of user Sam, or sorry, user Sam is a prefix of user Samantha. And this is the vulnerability. The vulnerability, and the reason this vulnerability exists is because when you call when you call the method getCanonicalPath on a Java file, you'll notice that the trailing slash gets dropped from the string. And so what you're comparing is not, when you're using this in a string comparison, you're comparing paths without the trailing slash. And so going back to this vulnerability, the example is, let's take user Sam and put those into the two locations in code where they're going to end up. And then we have a user supplied input that comes in, which is .. /Samantha/Baz. When that gets appended together, you're going to end up with user /Samantha/Baz, and this bypasses this guard. And so what's the fix for this vulnerability? Well, going back to the original example, what we're looking for is, this is one valid fix, where you re-add the slash back in. However, you're still doing string comparisons, and that's less than ideal. A better solution is to replace the getCanonicalPath with getCanonicalFile, turn that into a path object, and do starts with comparisons on the path object. Because Java's path object will do this comparison and do this starts with check correctly. So how do we find this vulnerability to actually fix it? Well, first what we need to look for is we need to look for starts with calls on the, you need to look for the starts with. You need to look for the string method starts with call, and then you need to look before and after and see the getCanonicalPaths on either side of that starts with call. But you also, if you're going to fix this vulnerability correctly, you also want to make sure that you're also filtering out cases where that separator character is being appended correctly. It can't be that easy though, can it? Well, developers also write code in a lot of different ways. What happens if the developer doesn't just write this, but they extract one half of this to a variable? Or they extract, the second argument to a variable. Or let's say that the correct logic is extracted to a variable. How do you identify this vulnerability still existing, even in the context of that logic being pulled out into a separate variable? We need this concept called data flow analysis. So data flow analysis lets us track the logic from the sources of variables and how they end up flowing to variables. And this lets us, for example, see that these variables are getting assigned to these different locations. And it can be more complicated than this. It can also go through intermediate variables. So data flow allows us to uncover hard-to-find vulnerabilities and prevents false positives. And the data flow analysis API is modeled after CodeQLs. So if you're familiar with CodeQL or you learned Open Rewrite, you can translate that knowledge back and forth between these two languages and these two frameworks to find these vulnerabilities and also fix them. And putting it all together, you can see in this example where the path was removed, or this path that was vulnerable gets replaced in this place. And so this is an example of the actual diff that was generated for partial path traversal. I have a brief aside story because it was just too funny not to tell. There's a case study of this vulnerability, CVE 2022-31159. The vulnerability existed in the AWS Java SDK, and it was partial path traversal. They created this guard which was checking to see if, while downloading the contents of an AWS S3 bucket, if the S3 bucket key was traversing outside of the destination directory while you were downloading the entire contents of the S3 bucket. And you can see that this partial path traversal vulnerability was being used as a guard against path traversal in this leaves root logic. And so this got a vulnerability CVE assigned to it. Everything went well fine on that. But there was a little bit of drama in another way. I had an email with the AWS security team where they sent me this email and they said, we'd like to award you a bug bounty. However, you need to sign an NDA for us to award you this amount. And I said, I don't normally agree to NDAs. Can I read it first, potentially, before agreeing? And AWS came back to me and said, we're unable to share the bug bounty program NDA because it and other contract documents are considered sensitive by the legal team. It was like Amazon used legalese and it hurt itself in its confusion. Like, so, story that just could not be not told as a part of this. All right, so the third vulnerability is zip slip. So people who have been hackers for a very, very long time are probably know what this is, but to summarize, zip slip is a path traversal vulnerability that exists while unpacking zip file entries. Because zips are just, a name of where you want the file to end up to the contents of the zip file. And so this vulnerability can exist in Java because it's very easy to unpack zip files. And so this is the logic that you'll see in a lot of places to unpack zip files. The SNCC team did a bunch of research back in 2018 to eliminate a lot of this vulnerability from the open source ecosystem. They reported it to a bunch of different open source projects, not just in Java, but other languages as well. Their fix was, for the most part correct, but there were certain cases that actually were still vulnerable to partial path traversal from zip slip. But that's neither here nor there. So this is the subset of the logic that leaves you vulnerable. It's that the entry name flows to this file output stream when you're copying the contents of this file output stream. So you're using potentially malicious zip files to download you're unpacking potentially malicious zip files into an outside of the destination directory potentially if the attacker has supplied a path traversal payload in the entry name. So zip slip is complicated. The zip slip is complicated because in order to fix it, you need to add this guard that protects against this vulnerability existing. You're checking to make sure that the file is within the destination directory. But the further problem with this is that even though that's a valid fix, there are other valid fixes as well. So this is one valid fix for it, but this is another one where you just put the logic inside of an if check. And so in order to determine if you are not going to be able to reach this logic, you need a new concept, and it's called control flow analysis. And so control flow analysis lets us determine that is there a guard in place that protects against this vulnerability or not, right? So the version on the left does need to get fixed, but the version on the right does not because there's a valid protection against this vulnerability. And control flow analysis did not exist in Open Rewrite prior to the work that we were doing, but when we added it, it enabled us to take take a chunk of Java and produce a graph, which is at every jump what chunks of logic are reachable. And so that lets us, for example, for zip slip, we can build a control flow graph for zip slip and traverse that graph and determine that if you reach the starts with call and that is false, then there'll be an exception thrown and that untrusted logic will not be reached. So it's a valid guard against reaching that potential vulnerable logic. And so when we put this all together, this is the example of the diffs that you can generate. Here's another example where you can see we've not only fixed the code, but we've also cleaned up the surrounding code as well. And so pull request generation, right? Let's go do some pull request generation. If you got security vulnerabilities, you can get a pull request. So the problems with pull request generation, one of the things that you'll run into really quickly is how fast can you generate pull requests. When you're generating pull requests, take a sip real fast. There are 3 different types of steps that you need to make. There's file I/O, there are Git operations, and there's the GitHub API calls. And file I/O is basically free because it's happening on your local machine. You have Git operations on GitHub, those are free, they're not rate limited. But then you have GitHub API calls that are rate limited. So the first step is you check out the source code and download it, which is a Git operation. And then you have file I/O, which is branching, applying the diff, and committing the change. Then you fork the repository on GitHub, which does actually so you fork the repository on GitHub, which is an API call. and then you rename the repository on GitHub, and you push the changes. Again, a Git operation. And then you create a pull request on GitHub. So of these things, there's 3 API calls. And the 3 API calls, there's a story behind this. There's a story behind this. You have 3 API calls that are rate limited by GitHub, right? And so GitHub recommends that for every request, or for between every request, you wait at least 1 second. Additionally, there are other rate limits that are in place that they want to prevent you spam users or malicious users from generating more pull requests. They don't want people spamming maintainers, right? Their users are maintainers, so they're trying to protect their users. So their protection of users, unfortunately, limits our ability to do this work as security researchers. So if there's anybody at GitHub in the audience, if you could stop rate limiting your API, or at least not doing it as much, that'd be greatly appreciated. So we've made it this far. Vulnerabilities have been detected, style's been detected, code has been fixed, and the rate limit's been bypassed. How do we do this for all the open source repositories that we want to fix? And I'm going to pass it back to Patrick to discuss Modern. Sit down button.
Well, first, let me make sure I've got it right side up. We'd like to, the Open Rewrite team, we would really like to thank Jonathan and Sham for their work. On behalf of Open Rewrite, I'd really like to commend Jonathan and Sham for their work to add control flow and data flow to the project. Not an easy task. These guys worked hard, they put their heads down, and they pulled it off.
Some context, Sham is my intern who has been working. He's in the back, but he was essential to making control flow something that was possible. So,
nice,
yes.
Nice job.
Yeah.
You guys rocked it. All right, so Modern is a company that's supporting Open Rewrite. And we provide a free service for open source projects. It allows you to run, our 800 plus recipes over 7,000 plus repositories. You can do your transformations at scale. You can find usages of types of method invocations all across either all of the 7 repositories that we have ingested or whatever you have in your organization. And it'll also generate an update pull request for you. This is really what's allowing Jonathan to scale. So as I mentioned before, the Open Rewrite, the suite of projects, we've got testing frameworks, logging frameworks, Rewrite Spring, Rewrite Kubernetes, you name it. We've got a whole suite of projects. We have more than 800 recipes, including complete framework migration. So, JUnit 4 to 5 is a really tedious transformation to make. We have a recipe for that. You want to get from Spring Boot 1 to 2, you need to do JUnit 4 to 5. We can bundle that all together so the developer is not having to sit there and bang their head on the keyboard and just work their fingers to the bone with all these tedious changes. So back to pull request generation. Jonathan is finding vulnerabilities everywhere. He's got a handy-dandy recipe to fix them, and now he needs to get those out. Modern also provides the ability to run that recipe across all 7,000 repositories that are indexed and generate pull requests for them. You can see they have a message that's contextual and yeah, lots of results. So I could talk about this, or we can kind of give you a quick little demo of a video. Here you can see it's run the recipe, it's generated some results, it's Jonathan putting together a message, he's signing his pull request, and off it goes. It's running through, building pull requests at scale. So now, as Jonathan finds those squirrels everywhere, he's got the tool to fix them.
So there's more than 7,000 repositories in the world. How do we find the other vulnerable projects, right? And this circles back around to what we were talking about at the beginning of the talk, CodeQL. So CodeQL, as I said before, it indexes over 100,000 open source projects and at least 35,000 open source Java projects. They support Python, C++, C, Python, Go, and I think there's some other languages in there too. But it lets you write queries to find these vulnerabilities at scale. And so those queries, because there's more than 7,000 open source projects out there, you can use CodeQL to identify the vulnerable projects, and then you need to make Open Rewrite aware of them, or the modern SaaS aware of them. And the way to do that is you just generate a pull, or you open a pull request against this repository and add to the CSV file, and then Open Rewrite will try to go out and build that project to index it and let you generate pull requests. So finally, let's go generate some pull requests. This is basically all of the giant pull requests that are projects that I've either been a part of or aware of. The only one that I actually was not directly involved in is the R hostname array one, where GitHub used my Python bot to generate those pull requests to fix an array overflow vulnerability. But the other ones, and these are all pull requests that I've generated, and for new pull requests as of 2020, I've generated over 590 pull requests. And to my name, across my history as an open source security researcher, I've generated over 5,200 pull requests. And one of the projects, funnily enough, the three vulnerabilities discussed in this talk, there was one unfortunate open source project that received all 3 pull requests. So yeah, and this is my GitHub contribution graph for 2022. It's not done yet, but you can see the impact of bulk pull request generation on that. And so now I want to talk to you about some of the best practices for bulk pull request generation. First off, messaging. You're dealing with maintainers. You're dealing with real people. There's a saying, all software problems are people problems in disguise. This is 100% one of those cases, right? You're dealing with actual people, maintainers of the software, and you need to be sensitive about that. You're not just disclosing a security vulnerability, or you're not just disclosing a bug in this. You're disclosing a security vulnerability. And so there's a certain amount of ego that gets wrapped up in this. We're challenging not just you've had a bug, which maintainers have been pretty normalized to, but you've had a security vulnerability that could put your users at risk. You're hitting them in somewhere that's different and they're not used to, and you need to be careful about that. So lesson 0. So lesson 1 about this: sign off on your commits. And this is what GitHub sign up. This is basically you add this to your commit messages. And why? Well, the reason why is there was a bunch of lawsuits, yada 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 yada. TLDR, lawyers. If you don't, your pull requests will be rejected by evil dragon bureaucrats. So GPGs, sign off on your commits. Lesson number 2: be a good commitizen. GPG sign your commits. So this is what signing your commits looks like. It shows up as verified, and you won't end up like somebody impersonating Linus Torvald on GitHub, because so if you GPG sign your commits, it'll prevent this. Lesson 3: there's a standard called CCOM, which is a commit format, and if you lay it out. Thank you.
Thank you.
So the story, I'll tell it when this is over. But yes, there's a story. I'll tell this when this is over. So thank you so much. I asked for.
We have a tradition where speakers are allowed to make an outrageous request when they submit their talk.
Yes.
If we accept their talk and we like the request, we'll fulfill it.
Yes.
However, we often fulfill it in sort of a slightly evil genie sort of way. So,
thank
here
you.
you are, quack quack.
Thank you, I appreciate it, yes. There's a longer story. So this is not the first duck that I've received. I spoke about the Zoom vulnerability, which I found at ShmooCon. And for some strange reason, somebody brought a duck up on stage for me, because I also use the duck in that talk. So I try to put the duck in every talk. And so I just said, hey, if you want to bring one, that'd be great. And lo and behold, they have. All right, taking a step back. CCOM, so it's a commit message standard for putting all the information in about a vulnerability into the commit message so that it's parsable. Yes, lesson number 4, there are risks to using your personal GitHub account. Anybody here who's familiar with GitHub's Angry Unicorn? This is GitHub's Angry Unicorn that occurs when you hit a 500 error. This was my GitHub profile for most of 2020. And the only way that I was able to fix it was by reaching out to GitHub support, and I'm also GitHub star, talking to them directly and asking to help. So you can break your GitHub account if you do this. Fair warning. Coordinate with GitHub. There's a benefit to doing this, because if you use your personal account and maintainers have issues and comments, you'll get notifications and you can engage with them, which is important from the communication side. So there are risks, but there is also an advantage to doing it this way. Yes, this is my GitHub profile for most of 2022. Coordinate with GitHub. I reached out to GitHub before attempting this. They want to know that you're doing this so that you're not spamming. They want to make sure you're not spamming people, so it's a good thing to do. And then lesson number 5 is consider the implications. Shortly after engaging in my most recent round of bulk pull request generation, I received this issue on my security research. I have a Leitschuh / security research GitHub repository. Is this responsible disclosure? Now, I use the term coordinated disclosure when I do vulnerability disclosures, which is the more nuanced term. But either way you're going to call it, coordinated disclosure, responsible disclosure, the answer is no. This is full disclosure of a vulnerability. You're ODaying them potentially. And there are implications there that you need to consider. I argue that given the scale of the amount of vulnerabilities in open source, it actually is a better net good to fix vulnerabilities like this than it is to not report them at all. Because that's the alternative that I'm facing. There's only so much time in a day that I have as a researcher. And so you're going to end up full disclosing this vulnerability, but the net benefit to the security of the internet is positive. And so I want to leave you with this conclusion. As security researchers, I feel we have an obligation to society. We know that these vulnerabilities are out there, and we know how to fix them. We've written pen test reports, we've seen them in source code reviews, we've had them come in from a variety of different places, right? We understand how these vulnerabilities exist. There's this problem in the industry. For every 500 developers, you only have 1 security researcher. This is from GitHub in 2020. So we are vastly outnumbered, right? And spoiler, a lot of developers don't watch BSides talks, don't watch Black Hat talks, don't watch DEF CON talks, right? It's the unfortunate nature of the world, right? So how are we going to be able to best scale our knowledge of math science technology, security, and the vulnerabilities that are out there to do the most good in the world? And I argue that pull request generation in this manner is the best way to have the most positive impact in the security world, or for the security of open source. And with that, I want to leave you with one final quote from Dan. This is on Dan's Twitter account. It's still there to this day. We can fix it. We have the technology. Okay, we need to create the technology. All right, the policy guys are mucking with the technology. Relax. We're on it. I want to leave you with some sound bites. Learn CodeQL. It's a really powerful language. It's not easy, but you'll get it. Like, it takes a learning curve, but it's worth learning. You can do a lot with it. You can find really cool vulnerabilities. It's really cool writing a query and just having them fall out of open source. It's really that easy. They just start falling out of the open source code. Contribute to Open Rewrite, and you can deploy your security fixes at scale. And then join the GitHub Security Lab and Open Rewrite Slack channels, where you can discuss with me and other security researchers who are trying to tackle this problem of open source security to fix these vulnerabilities. And I'm also going to toss on there, if you're interested in open source security in general, consider joining the Open Source Security Foundation, which is it's a project under the Linux Foundation, where a lot of the discussions around the security of open source are being discussed in working group meetings every single week. So. And then finally, I want to say thank you to Human, my employer, Modern, for being spectacular in enabling this work to even be possible. Lydia, who helped she was the Black Hat speaker coach that we ran this by like way too many times to get this into the state it was in. And then Sham, my intern, who was instrumental in allowing control flow analysis to exist. Also the graphics for control flow were some of his work. So thank you. That's us. Questions? Go. Yes.
First of all, excellent talk. Very high quality, high content. I'm in the ASD space, so I completely grok it. I completely get it. My question for when it comes to rewrite, which is a very important technology, all the examples I saw seem to skew towards Java. So what are the languages that also rewrite support with the advanced ASD?
Okay.
So, repeat the question.
Oh, yeah. So your question was, what other languages does Open Rewrite support besides Java? We have XML. Let's see.
XML, JavaScript.
We're working on JavaScript.
Yes.
Working on COBOL.
Yes.
HCL.
Kotlin's in the works.
Properties.
No, not JavaScript. Not JavaScript currently. JavaScript's in the works. Java. Gradle build files.
That's right.
Groovy. Yeah, so it's predominantly Java currently, but there's a lot of other work going on to support a bunch of other languages too. So, yeah. Anybody else? Going once? We'll take any questions, I promise. Going twice? What?
You should have asked for the USB doc. We weren't specific enough.
Yeah. So yes, I try to put the WAT duck in every single one of my talks, and yes. So this is a callback to that, but also to my previous Zoom talk about the O-Day that I dropped in Zoom back in 2019. So go back and if you're curious about that vulnerability, go back. It's ShmooCon. I talked about the Zoom vulnerability that I found. So any last questions? Yes, go for it.
Yeah, it seems like the best practice are attempt to kind of mitigate the weaponization of open rewriting, get that right, assigning commit, it's not something you need to buy.
So the question is, the goal of the best practices is about trying to mitigate being evil, and it's not just about mitigating being evil. It's like you're dealing with real people, but you don't want to come across as a bad actor, right? Because GitHub will ban you if you're a bad actor, right? Like, I mean, they will take into account like you're trying to do the right thing, but like you don't want to get banned from GitHub. It's about trying to do the right thing in the context of also fully disclosing a security vulnerability in public. If there was a way to do this in a way that was private, if GitHub supported private issue, like creating a private issue or a private pull request, I would 100% go down that route. It just does. It's not supported by GitHub currently. John, looked like you had a question. No? Okay, just checking. Yes, go for it.
Follow-up. So you mentioned if you want to get involved, what I'm going to do is security.
Yes.
Are there any other like kind of mature organizations that have gone on to do this?
A little louder.
Yeah. Is there any other like OSS that has guidelines for doing what you're doing? Most of them are rewrite or open source security foundation or like
Are there organizational bodies around this sort of effort?
or if they have best practice?
No, there's no. So as far as I'm aware, work like this around fixing vulnerabilities at scale in this way, I am not aware of any other large-scale efforts besides the ones that I've engaged in to do this. Now, I've seen, for example, I've seen the Jenkins project go and generate a bunch of pull requests specifically for the Jenkins project. So that's the security team from Jenkins doing that specifically. But I have not seen, there's no major project that is actively engaged in this. This has been something that it's been a project that I've been passionate about, and that's why I applied to the Dan Kaminsky Fellowship saying, I do this thing, I have done this thing, I want to do more of it, and they accepted my application to enable me to try to see what I could do in a year, to scale this thing that I've been doing as a side project into a full-time job. So this was my full-time job for the past, since January, was working on this project. So that's what enabled this. I would love to chat if you want to do more of this, because I want to do more of this in, like, I think that more of this is awesome. Yeah. Anybody else open to any questions? Or you can also come chat with us afterwards. I think that's, anybody? Okay. Thank you all for coming. I really appreciate it. Thank you, thank you. And if you want to chat with us, or you can reach out to me on Twitter, I'm also available there. So thank you.